Okay, Addison, we are adding and subtracting. We've only got a little bit left, and then, excuse me, a little bit of the back page. So, we just got done multiplying, dividing, right? Multiplying, dividing. Maybe I should have said, if you are dividing, you keep flip, flip. If you are multiplying, you keep it. You just, like, do the thing, right? Okay? So I didn't say that yesterday, but maybe I should have. But then you want to break down as much as possible, and you want to reduce. Now, real quick, when you are multiplying, dividing, let me do this real quick. Let's say I have x squared plus 4x, and then I've got 3xy squared times, goodness sakes. Let's go this, and then let's go like this. I'm making up an example, okay, because I want to talk through this example. We didn't run into anything like this yesterday when we were doing examples, but you had a question like it on your homework assignment, so let's talk about it, okay? So we are multiplying. We don't have to flip anything, but I'm going to go through piece by piece, and I'm going to look and say, can I do anything to that? So this guy, can I do anything to that? I'm going to pull an x out, and left over is x plus 4, okay? Can I do anything to this 6x squared y cubed? No. Can I do anything to this guy? No. Can I do anything to this guy?
Yes.
Yes, he is.
Difference of squares.
X plus 4x minus 4, right? Now, here's the deal. We ran into this yesterday, okay? And I kind of go through my multiply divide on like based on things that are trapped together and things that are not trapped. So like this guy right here is trapped. He's got to go as a full unit, right? These guys are not trapped. So if I have x's here that I want to cancel with an x down here, I sure can do that, right? Yeah. Same thing down here. These are not trapped, but these are yes trapped, right? So they have to go as full units if they're adding and subtracting. Otherwise, you can just cancel one for one. So here's what I'm going to do. I'm going to cancel the x plus 4 and the x plus 4. Then what I'm going to do is I'm going to do a cleanup step where I just multiply like across the top. So I've got this x and this guy here. He is 6x cubed y cubed, right? Because now I have that extra x, okay? Then I've got 3xy squared times x minus 4, okay? And now I want to reduce these guys, right? So 2 and 1, and I'll have 2 left on the top, and I'll have 1 left on the top. So on the top, I can do that. So things that are trapped versus things that are not trapped, keep those kind of differentiated so that you can know what you cancel and what you cannot cancel. Yeah? That was a made-up example. All right, now let's go to adding and subtracting. When you add and subtract, kind of like adding and subtracting fractions, you must common denominator, which is also called the least common multiple, right? The least common multiple, the lowest common multiple, okay? All right, so let's go down to example 4. These guys right here. These bottom pieces are not trapped, right? Okay? But we want to find a number that both 4 and 10 will go into.
40.
No. 20. I want the least number, right? I want to go 20. Okay? Did you say 20? I'm sorry. I can't hear. My ears are plugged right now. I heard somebody said over here 40, so that's what I was going off of. Okay? Now, A's and A squared. How many A's do you need?
3.
You only need 2, because does this A go into A squared? Does this A squared go into A squared? As long as they both will fit in there, he's fine. So when you're doing variables, the trick is that you want to take the highest power. Okay? So A squared. All right, now, what I'm doing is I've got a 7 on the top here, and I've got an 11 on the top here. And I'm going to multiply by what they need. So I'm looking here from 4A to 20A. How do I get from 4A to 20A? I need to multiply by a 5 and another A, right? Okay? Now, how do I get from 10A squared to 20A squared? He just needs to be multiplied by 2, right? Okay? So this guy is 35A, and this is 22. Can I put those two together? No, but I'm going to put everything under one roof. So I just have 20A squared on the bottom, and I have 35A plus 22, because I cannot combine those. And that is all. Okay? Do we remember doing this? Yep. Little bit?
Yeah.
What is that? Yeah, the piccolo. That is so tiny.
Just think, I should have the theory run. It's the same finger and it's a flute, just tinier, smaller.
And higher pitched, right?
Layla chose the flute, so she's excited.
Lucky you.
All right. Okay. All right. Adding, subtracting. What? She's in 5th grade. Isn't that crazy? Now we are subtracting. Okay, there's a little trick that I've started teaching kids when they are subtracting. Are you ready for this? Okay. There is a little trick when you are subtracting. Because I have a lot of kids do this wrong, and they only apply the negative at the end to this X right here. So here's what I do. Here's my little trick. Change this to a plus sign, and then flip the signs here like you've dragged the negative through the back piece, right?
Just the top?
Just through the top. Just through the top. Right? Because if you apply a negative to the top and the bottom, that cancels out, and it makes a positive, right? Okay? So that's my little trick. That's my little trick. Anytime you see a minus, change it to a plus and distribute the negative through so you don't forget to do it later. Got it? Okay, now we need to find a common denominator. But before we do that, let's break the denominators down. This is a simple trinomial. What can you multiply to get 3, but when you add them, give you 4? Positives for both, x plus 3, x plus 1. Okay, also simple trinomial over here. Multiply to get negative 3, add to get positive 2. X plus 3 and x minus 1, okay? So now we got to choose what our denominator is going to be, right? Now it's plus, right, in the middle. So I'm looking at my denominator, and I'm going to go through, and I'm going to do like a checklist. I know that in my denominator, I need an x plus 3. I know that in my denominator, I need an x plus 1. I know that in my denominator, I need an x plus 3, but I already have one. So I don't need it again, right? But then I need an x minus 1. Okay, I need all 3 of those pieces. I'm going to write them over here as well. Okay, the more you do this, the more steps you can skip, right? Like some of you guys can do this in your head a little bit, okay? All right, I'm going to write my 3x plus 5 up here, and I'm going to put him in parentheses. And then this guy is negative x plus 5, and I'm going to put him in parentheses, okay? Now I'm going to get ready to put... Yeah, hold on. I'm getting ready to put what he needs, right? Okay, so here he's ready to go. I have my common denominator. I just rewrote my tops. Okay, now I'm comparing this guy to this guy. X plus 3 and x minus 1. He is missing the... Did I say x minus 1? I meant x plus 1. He is missing the x minus 1, right? What's this guy missing? X plus 1. Okay, now what do we do? Now we got to FOIL the tops, right? So if I FOIL this guy right here.
Why do you have to FOIL it?
Because we gotta simplify the top guy. So if we FOIL the top, he is 3x squared minus 3x plus 5x minus 5, yeah? I'm going to leave that like that because we're going to simplify him with this guy over here, okay? So this guy is negative x squared minus x plus 5x plus 5. Is that true?
Can't you just cross? Yes.
Yeah? Okay? Now, I'm not going to distribute the bottom through because I'm going to be lazy and I don't really care. So I'm going to leave him with my 3 groups. X plus 3, x plus 1, x minus 1. Right? That's going to be my final answer. But now I have to combine like terms on the top. Okay? So I've got 3x squared minus x squared is 2x squared. Yep. Negative 3x minus another x is negative 4x. 5x plus another 5x is plus 10x.
Can't you just combine them?
Oh, gosh.
They're the same thing.
Blah, 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 blah,
10 minus 4
blah.
is positive 6.
My brain is like really just negative 5 plus, yeah, blah, 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 blah. So plus 6x because all those go together.
That's it.
I'm used to only doing 2 at a time.
The 5's cancel.
Then the 5's cancel. So that's it.
Shebang.
Shebang.
Shebang, shebang.
Shebang, shebang.
No, maybe. Don't say that.
Boozy?
Don't you mess with
I
one, too.
love Jaboozy.
Don't you mess with one, too.
Homie messed it up, not me.
Now,
On the Shibuya's terrible.
one more thing really quick.
Uh-oh.
One more thing really quick. If you get that as your answer, that's totally fine. But guess what this top guy is? If you pull a 2x out, he is x plus 3.
Whoa! He's a difference of squares.
No, he's not.
No, you have to do that.
So you could cancel the x plus 3's and just get 2x over x plus 1, x minus 1.
How are we supposed to see that? Like, we don't have the brain like you to just
That's why I said this is fine.
You just gotta have the combi.
That's why I said you just got that going on. Okay? But just so you know, that might be a thing also. Okay?
Wait.
But if you get it to that far, that's totally fine.
Next.
Just so you know, that's a thing. Okay?
Ew,
All right, is this the last problem?
No,
it's not.
no,
Woo!
We got 2 more.
How do they have it like
Yeah,
Okay.
I'm out of time.
We'll do example 6. We'll skip example 7 because they're like basically identical. All right, this guy. What does this bar right here mean?
division?
Division. All right, so we're going to deal with the top part first. So we're going to do this guy. And in order to be able to subtract those two, I have to find a common denominator. So I'm going to go x over 4 minus 4 over x. I'm just going to rewrite him, but I'm going to change this to plus minus, right? So I don't forget it, okay? Now I need a common denominator.
4x.
4 and an x, and a 4 and an x, and an x, and a negative 4. Okay, so I've got my common denominator ready to go, and I need to multiply by what he needs. Okay,
X squared.
I'll get you there. Are we good to go? What does this 4 need? Or what does this first guy need?
X.
He needs an x. I'm going to put an x here. What does this guy need?
A 4.
A 4, all right? So on the top here, my top part is going to be x squared minus 16, which is the difference of squares. And the bottom is 4x. Okay, I'm not going to break down the difference of squares yet. Okay? Now, that is that, right? Now we got to deal with this guy right here. So I'm going to deal with him over here. 1 over 4 plus 1 over x.
Are we actually dividing or are we flipping them?
We will here in just a second.
X plus 4
Okay.
over x.
So
Now.
we've got this guy going on. This is the bottom, right? This is we're dealing with the bottom. What's your common denominator? 4x and 4x and 1 and 1, right? And we need to multiply by what he needs, right? The first one needs an x, and the second one needs a 4. So he is x plus 4 over 4x. Okay,
Do the bottom?
now
No, we're dividing. Right?
this was my top, right? And I am dividing by this, right? So I'm taking that guy and I'm going to instead multiply by
By
4x over x plus 4.
Now they're going to cancel.
Yeah. Now the 4x and the 4x are going to cancel, but we know that that's a difference of squares. X plus 4x minus 4, right?
Get rid of these.
So the x plus 4s are going to cancel. So the final answer is x minus 4, and that's all. Woo!
That's dumb.
That's just.
Okay? Good?
Sure.
All right, we're not going to do example 7, but I'm going to talk about him real quick. Okay? These are negative exponents. Negative exponents. But the problem here is I can't take this d to the negative 2 and put him down to the bottom to make him d squared because he's trapped with the minus c to the negative 2. So here's what I have to do. Here is my big division symbol. Whoop. D to the negative 2 is 1 over d squared minus 1 over c squared. Because they are trapped together, I have to leave them on the top together, right?
Can you make that
Then the bottom, what's the bottom look like?
1 over D?
1 over d minus 1 over c, right? And then you do the same process as what we did up here, right? You simplify the tops, you simplify the bottoms, then you keep flip, and it's going to cancel stuff, right? Okay? Do you want to do it or you want to skip?
Skip.
Skip?
Wait. Miss Wright's texting. Yeah, because it's Megan. Doesn't Megan have her phone?
She's what?
She just said
Yeah, it's Megan.
Megan.
Yeah, but why is she texting us? You know, we're not with our
Because she's not an idiot.
I don't know.
Let's
I don't
send
know.
an email out
Okay.
to kids.
All right, let's do example 9. We don't have an example 8. We just have an example 9. All right. Now, the last thing is something called rationalizing. We do this a lot in trig, like a lot, okay? Now, when we look at this guy right here, 5 over the square root of x, this is considered to be improper, okay? It's like an improper fraction changing it to a mixed number. We do not like to have a square root in the denominator.
What page are you on?
Okay.
I'm on one of the pages cut.
All right, we do not want a square root in the bottom. So what we're going to do is to rationalize. This is the process of rationalizing, okay? We're going to make him rational. So we are going to
Square root times
multiply by the square root of x over the square root of x. Now, real quick before we move on, what is the square root of x divided by the square root of x? 1. So I'm taking this guy times 1, and when you take something times 1, it doesn't change it, right? So I'm not changing the value of this thing, I'm just changing what it looks like, right? What is 5 times the square root of x? 5 square root of x. What is the square root of x times the square root of x?
X.
Is the square root of x squared, which is just x, it just pops out, right? And that is now a rational expression, like it is better, okay? You guys will get to the point where you can do that in your head. You probably could already, right? You know that it needs to be the square root of x over the square root of x, right? Okay. Now, when you have pluses and minuses, when you have two pieces on the bottom, was I going too fast? When you have two pieces on the bottom there, how do I get rid of him? You have to multiply by the conjugate, right? What's the conjugate of the square root of 7 minus 5? The square root of 7 plus the square root of 5.
The one that did like all the activities.
Okay, but what I do to the bottom, I have to do to the top. Shh. Shh. Okay? Square root of 7 plus 5, square root of 7 plus 5, because these guys are conjugates. Okay? Conjugates. All right.
Hey, so technically, wouldn't we have to do the negative square root of x?
What?
No, because there's
Wait a
no.
minute.
Well, how come we changed it to plus?
Because you can't do a negative.
Conjugate.
Yeah, you made it negative square root of 5, which is plus.
You can't do
No,
a negative
no.
square root. He's talking about the one back.
Go back.
Like, back a problem. Why didn't you make it the negative square root?
Because he's not trapped. You could. Okay, here you go. You could. No, hold on. You could multiply by a negative and a negative, right? But then that's going to make this bottom negative x, and that's going to make this top negative x. So the negatives are going to cancel anyway. So do less work. Technically, if you want to multiply by the conjugate, yes, it would be negative. But the negatives are going to cancel out anyway. So the trick is just multiply him by himself.
If it's trapped.
But if it's got two pieces, you got to do the conjugate. Okay?
Then it doesn't cancel out.
It will cancel out. Okay, let's do the top. So if I'm multiplying 4 by this guy, what's 4 times the square root of 7? 4 square roots of 7. He does not go inside of there. What's 4 times the square root of 5? 4 square roots of 5. Okay, that's what the top is, and he is done. Okay?
Oh, it's 7.
Now the bottom, we do the FOIL method, right? What's the square root of 7 times the square root of 7?
7.
Just 7. It's like the square root of 49, right? What's the square root of 7 times the square root of 5?
Cancel, but that don't matter.
Plus the square root of 35. I'm going to write it down. You just be quiet, okay? Now if I do the middle pieces, negative square root of 5 times the square root of 7 is negative square root of 35. So Brady's yelling. He's mad. Just don't do it. Yeah, they should cancel out, right? Because that's why we're doing the conjugate. Okay, then we do what's the negative square root of 5 times positive square root of 5? Negative 5, right? Negative square root of 25, which is 5. Okay, now the middle two pieces cancel. And the bottom is 2. So I have 4 square roots of 7 plus 4 square roots of 5. But we're not done yet because this guy and this guy and this guy are all divisible by 2.
Get 2 squares of 7 plus 2 squares.
2 square roots of 7 plus 2 square roots of 5. Now, here is why, just so you know, here is why you have to be able to take it out of all 3 places, because these guys are trapped right here. Technically, what you are doing for this piece is you are pulling a 2 out front, right? That's what you're doing. You're pulling a 2 out front, and then these 2's will cancel. So that's why you have to have it in all 3 spots in order for the 2 to reduce. So this is your final answer. Got it? Okay, there you go. All right. Okay, 6 left maybe if you get the first 7 done. All right. Yep. Okay, bye, Addison.